Hey, well, good morning, friends. Welcome to another day of Heaven Geometry. It's nice to see you guys. As you can see, this is a casual edition, so I hope you're comfortable because so am I, and we've got a lot of fun to have today. So this is homework 8.1. Good job overall on the Chapter 7 test. But what I'm going to be doing is for each lesson now, moving forward as we start a new chapter, is you'll have the homework, and I'll be going over the entire homework with you right here on the board for Chapter 8.1. And then you'll have the classwork that you can work through and practice as well. And that's where you can request specific problems that I can either help you individually or make videos for it to help you. I might probably also make a supplementary video with maybe one or two problems as examples. But this is going to be homework 8.1. So hope you're comfortable. Put your cereal aside because I know you're hitting this first thing in the morning. Who would want to wait for geometry? And feel free to watch it, rewind it, and watch it again. Invite your friends over, watch it again and again because it's just too much fun. Sorry, feeling kind of sarcastic this morning. So, okay, Chapter 8 is going to be a really important chapter because it's all about right triangle. It's actually the beginning of trigonometry, which is really cool stuff with triangles. Chapter 8 is going to seem a little confusing at first, but I'm going to try to give you I'm going to give you why it works briefly, but then I'll just get nuts and bolts, say here's how you do it, here's the formula, in order to just for those of you less interested in why it works and you just want to be able to make the calculations and get the answer and get out. So we're going to define geometric mean, and then we're going to answer the 4 questions from today's homework. So let's get started. Let's see, actually let me grab my handy calculator. Not sure. I don't think we're going to need it, but I just want to have it ready. Okay. So geometric mean. Geometric mean, the more complicated sense is that, again, if you remember, if you write a proportion of something like A over B is equal to, say, B over C, okay, and say we were going to solve this proportion, you would cross, multiply, and divide. A lot of you did that really great yesterday on the test. So if I cross multiply, okay, I get B squared equals A times C. And so if I wanted to solve for B, I would then take the square root of both sides. And so B is equal to AC. Now, so when we're saying, if you remember, in a proportion, the two outer numbers, A and C, are known as the extremes. And these two middle ones, which I use B for both, this is known as the means. And so all the geometric mean is a shortcut to finding, basically to solving a proportion quickly. And so, practically speaking, what this means is if you want to find the geometric mean of two numbers, you are going to, let's just say you have numbers A and B, and you want to find the geometric mean of A and B, you're just going to multiply A times B and then take the square root. It's a shortcut for solving a proportion that has the same side included. Because you can see if I have the same side, A to B is B to C, and you'll see how that comes in with this triangle. Then you could, again, set up the proportion, cross multiply, square root, and then find that value. But again, practically speaking, when it says find the geometric mean, take two numbers, multiply them together, and take the square root. So, for example, we'll do these in a second. So question number 2, actually we'll just jump to question number 2. That is finding the geometric mean of two different numbers, 2 and 8 and 4 and 9. And so we're just going to multiply the two numbers together. So we just do 2 times 8, and then we're going to square root that. So 2 times 8 is 16. The square root of 16 is 4. And so 4 is the geometric mean of 2 and 8. And again, if you care, that just means that 4 is the common side within a proportion of 2 to 4 is the same as 4 to 8. So the geometric mean provides that mean between two extremes in a proportion. Again, you don't have to worry about that so much. Just remember, if all you care about is solving it, multiply and square root. So the geometric mean of 4 and 9, 4 times 9, I've made these nice, is 36. Square root of 36 equals 6. And so 6 is your geometric mean of 4 and 9. And again, I could show you 6. 4 to 6 is proportional 6 to 9. Okay? Now these two are nice. Let me just throw you one more. Again, pick any random number. Say, let's see, what do you think, Cyrus? Yeah, 5. Say 5 and Maya 8. Good. So 5 and 8. Okay, find the geometric mean. You're going to multiply. 5 times 8 is 40. Now this is what I mean by not as nice. Is now square root of 40, it's not a whole number like 36 and 16, but you're going to run into that a lot. We did that already in previous chapters. So we have the square root of 40. The way you simplify that is you look for a square root within 40 a number you can take the even square root. In this case, 4. So the square root of 40 is the same as the square root of 4 times the square root of 10. And again, I chose to break it up that way because I can take the square root of 4. And so the square root of 4 is 2. And I leave the square root of 10. That doesn't simplify. That's 2 and 5. Those can't take the square root of 2 and 5. So that's just 2 times the square root of 10. Okay, and so this is, maybe we'll do another little video, or I'll link a video reminding you how to simplify radicals if they're not as nice as 16 and 36. But this answer would be the 2. The geometric mean of 5 and 8 would be 2 square root 10. Square root of 40 is correct, but you do want to learn how to simplify that. Okay, and we went over that before, but you want to keep practicing it. Okay, so that's the geometric mean. And now we're going to see how that plays into triangles, right? Specifically right triangle similarity. Is the whole chapter, all of chapter 8 is right triangles. So the first question asks, what happens if you draw an altitude from let's go ahead and mark this down as a right triangle. And so if you remember, an altitude is a perpendicular line that connects to the opposing vertex. So if we take a perpendicular line from the hypotenuse and we go up to the vertex, what happens when we draw that? Can you see? Isn't that amazing? Look what happened. There's a red line there now. Isn't that exciting? So what happened is we have now created, and we're going to call this new point here D, because you'll see why in a second. We've now created 3 triangles. We have our big triangle, ABC. We have another right triangle here, CDA, and we have another triangle, CDB. And the big point of this lesson, this question, is now you've created 3 triangles. I'm going to now draw those triangles separately. Let's go ahead and switch colors here. Oh, we'll do one in each color. We've got the big triangle. We've got big triangle ABC. Won't redraw that one. Then we have another right triangle. A, D, C. That's this one kind of like here. And then we have another right triangle, the littlest of them all. Not drawing them very well. And that right triangle is C, D, because here's another right angle, B. And what happens, the question, you'd want to draw this out for this question, because what you've now created, and that's this triangle right here, is you've created 3 triangles, Papa triangle, Mama triangle, and Baby triangle, and they are all similar. You've created 3 similar, or another key, what that means is proportional triangles. So that means that we can use that, again, all the hypotenuses to the legs, these are all proportional. So like what you were doing in the last chapter, if I said this distance on this triangle to this distance is proportional to this distance, or this leg to this leg. Or if I said, oh, this hypotenuse to the short leg is proportional to this hypotenuse to that short leg, or this hypotenuse to that short leg. And so that means that when you take a right triangle and you have the altitude, you can solve all these distances very easily using proportions. I know, exciting, very exciting. And so that question number one is the fact that, okay, so now we have three proportional triangles, and you want to be able to draw that and recognize and label the three, because you can say I took this one out, kind of flipped it, and that made this second triangle, and then this one here, pulled it out, and now you have that proportional triangle. So question number three, there's two corollaries, rules, pieces of information, principles that we can pull from that, and that is how to solve the distances within this. There's kind of two shortcuts to that. I will give you a long answer, and again, you can fast forward if you just don't care, and then I'll show you the shortcut. But I do want to briefly show you why it works. So let's go back. Let's start with this, and what I'm going to want to do with well, actually, maybe I'll just redraw that triangle. So if we have a right triangle, okay, we've created our altitude there. We're going to call this A, B, C, D, and then I'm going to label all these distances by variables. So this altitude we're going to call X. We're going to call this Y. We're going to call this long distance here Z. We're going to call this one W, and D to B I'm going to call V. Because those are what you're going to be finding. You're going to be finding all these different lengths. And so keeping in mind that we've created, all these sides are proportional to each other, you can write proportions using these distances, and it creates basically, you'll see there's a shortcut to it rather than doing it the long way. So for example, let's look at the big triangle here. Let's see, maybe the easiest way. The big triangle here, let's do the legs to the legs. So for the big triangle, Z to Y would be the same as X to V. Okay? Because there's the two legs. Now if we cross multiply and divide,